Sitting alongside the beautiful Benjamin Franklin Parkway in the heart of the city's cultural district, the Academy of Natural Sciences of Philadelphia, founded in 1812, is an active research institution and scientific resource to this day. Since its beginning, part of the mission of the Academy has been the advancement of useful learning in the natural sciences. As the oldest natural sciences institution in the Western Hemisphere, it has provided scholarship and materials to fulfill this mandate as the needs of society have changed over the years. Its collection now houses over 17 million specimens and continues to grow, with Academy scientists traveling around the world on expeditions to support their research projects. More than 60 years ago, the Academy established the Environmental Research Division, which included applied research in aquatic ecosystems, at least as relevant today, especially in light of the devastating oil spill in the Gulf of Mexico in 2010. That disaster has brought home some very important points.
One is what better precautions we could take in drilling in deep sea environments. I think we've learned our lesson that you need to have some sort of backup plan in place in a lot of these environments. Number two, we'll learn a lot about how the environment, how resilient or not resilient the environment is. Will the marsh plants be able to help degrade some of the oil? Will the transport and the dispersants that were applied, how will those move or help degrade the oil?
In the short term, fish and other aquatic life will ingest hydrocarbons and incorporate them into their soft tissues, but these will gradually disappear.
What you will see is certain indicators of the oil could be trapped within the calcareous matrix of their shell, things like trace metals, vanadium, molybdenum, zinc, and other metals that people study.
For this reason, the Academy's extensive collection of mollusk specimens, begun in 1812, is an extremely valuable resource for scientists around the world.
These are part of our very large collection of shells, and particularly what we're looking at here are eastern oysters, mostly from the United States. Some of these specimens are very old in that they were taken a very long time ago. So this is a cluster here of oysters growing on an old wine glass, probably out of New York Bay. Here is one taken from inside an unbroken beer bottle in 1903. And these are very important specimens because they do have their dates with them. When you look at a shell, that it grows rather as a tree grows, it gets larger and larger, and there are rings on the shell that correspond to little units of growth, and some of those units, if you get down to microscopic levels, they represent days. As time goes by and the environment is degraded or changed in many ways, having these shells allows us to go back in time and to understand what the chemistry of the water was back in those days. And so when scientists need to form baselines, they need to understand what conditions were like in the Gulf before there was any oil drilling. They have to come here and use our specimens because we are one of the few places that has maintained this record of dated specimens over such a long period of time.
The scientists at the Academy are not just helping to look back in time. One project is to investigate organisms that may produce useful drugs and industrial compounds for the future.
And natural products research has two areas. One is looking for things of pharmaceutical potential. So we're looking for central nervous system activity, antimicrobial activity, anti-pain. Then the other aspect of the research is to be doing dissections of various species of cone shells and looking at the bacteria that live in them and see if there's any effects from the bacteria producing toxins that might also be amplifying the effect of the cone snails. The other thing we're looking at is bacteria that produce cellulases. So things like shipworms that bore into wood need some way to digest the wood. So the cellulases can be used for that. There's probably a bit more potential on the biofuels side, since there are a lot of enzymes necessary for converting various kinds of biomass into fuels. Shipworms live in various kinds of wood, so what we look for is pieces of wood lying on the bottom that we can bring back up and take apart, looking for the shipworms. They're actually very difficult to extract because you can see that their burrows can be intertangled, and there can actually be as many as 5 or 6 different species of shipworms living in a piece of wood in the Philippines. I think so far we've found 16 species altogether. And so each one of them is potential for discovery of interesting bacterial species.
As the Academy of Natural Sciences of Philadelphia enters its 3rd century, its scientists continue to travel the globe, documenting the natural world and advancing useful learning.